when we are looking at this picture, we're going from the base graph in pink to the transformed graph in black. The only thing that's unaffected by a stretch or reflection is the number 0. Well, lucky for us, we know that on the original graph, our starting point is at 0, 0. We also know that the mapping for this particular generic function is going to be this. It's going to be 1 over b times x plus h, a times y plus k. Now on the original graph, I know that one of my key points is 0, 0, and when I put it into here, the parts that are multiplying go away because my x and y's are 0, and because I know my coordinate right here is 4, 2, that's the start of my other function, my transformed function. Hopefully you can deduce pretty quickly that h is 4 and k represents the 2. So now what we're trying to figure out is the b and the a, and it could be one or the other or both. Let's pretend, just for the sake of it, that I have transformed the point 1, 1 to the point 5, 5, so that the second point on my transformed graph represents the second point on my original graph. In the last unit, what we did is we compared the height and width of each of the points and determined the expansion that way. We said, okay, from 0, 0 to 1, 1, it was 1 and 1 for the height and the width. For my transformed, the width is 1 and the height is now 3. So I could say this is a vertical expansion by 3. But I don't know for sure that that is the point. But let's just pretend for now that it is. If it is, then I don't have a horizontal expansion or compression. I only have a vertical one. Right? Now, on the other hand, if I said, now I'm going to graph, I don't know, let's say 9, 3 to 5, 5. Now what's the difference? Well, from my original, it was the length of 9 and a height of 3. But on my transformed, it's a length of 1, height of 3. So my height hasn't changed, but my horizontal has changed. Now I've divided by 9, so I have a compression by 9, right? So there's different ways to see it. If I tell you the mapping, then you can go by measurements. But because we don't know what the mapping is, we have to say, okay, there's two possibilities here. So let's take a look at what would the equation look like for each instance. So down in the bottom, we are going to substitute h and k with the numbers we know, and we are going to use the point 5, 5 for our x and y. And we are going to see what would it look like if we focused on the vertical stretch. So that means I'm going to rewrite this equation, substitute every single number except the a. My coordinate is 5, 5. So 5 equals a square root 5 minus, what was my h? 4, whoops, plus 2. Because I know the h and k, and I'm choosing a coordinate on the transformed graph. You could choose any. I'm just going with the 5, 5. Okay, and then we simplify. What would this simplify to? 1. So this is telling me that 5 equals a plus 2. So what's a? It's 3. Which is what we observed when we said, let's pretend 1, 1 maps to 5, 5. That's kind of what we got, right? So my function would look like this. Y equals 3 root x minus 4 plus 2 if I viewed the transformation as a vertical stretch. If instead I view it as a horizontal stretch, then I'm going to do exactly the same thing, but instead of solving for A, I'm going to solve for B using all the same points. 5 equals square root B bracket x minus 4. Oh, sorry, not x. I'm going to use the point 5. 5. Okay. Plus 2. What's my first step? I want to solve for the B. Bed mass backwards. What am I doing first? Minus the 2. So this is 3 equals square root B. And what's 5 minus 4? 1. So I actually don't need to extend that. The square root of B equals 3. So what's B? 9. Right? Because to get rid of a square, these are opposites. Okay, so now if I view this as a horizontal stretch, then my equation would be square root 9 bracket x minus 4 plus 2. And both of these equations are going to give me the same graph that I saw at the top of the page. Okay? The reason this is different than the last method is the last method told you the 2 points so you could actually measure length and width. When you don't know, you have to pick. Am I going to do an expansion or a compression? And choose a point you're going to use as your map and solve for the stretch, whether it's horizontal or vertical. Just make sure you're putting the letter in the right spot. Okay? That brings us to the end. Your homework for today is section 2.1 odds. It's about 10 questions. Yep.